Alright guys, hopefully you did pretty good on that quiz. We will again see that a couple times. You guys are gonna help me fill these out, okay? So we're on the notes. We've already talked about a lot of this stuff. So hopefully you guys can help me out with this. A polygon is what? Someone raise their hand and tell me what a polygon is. What do we have? A closed figure. Okay. What else?
You have to start with it.
It has straight edges.
Closed figure with what now?
I thought it had straight crossover or curves.
No curves and no crossover. Okay, let's draw three counterexamples. One would be a circle because it has curves. Another counterexample would be sort of like an open something like that. And thirdly, I'm going to draw a bow tie. I'm going to make it go this way. Like so. Those are counterexamples. I'll write that down here so you guys can see them. Counterexamples. Okay, so those three in parentheses are not polygons. A circle's not because it has curves. The second thing is like an open, it's like kind of like a glass or something like that, I guess. Like you could put liquids inside of it. And thirdly, it's a bow tie. It crosses over. It's like something that's like twisted. Okay. Each line segment is called a blank of a polygon. This is way too easy. You guys are thinking too hard. What's the line? A side, yeah. The side of a polygon. Okay? It's pretty easy. So the side is basically a line segment of a polygon. Each endpoint where the sides meet is called a, this is tougher, cool name, supposed to be vertex.
So you said
Vertex is one. If we have like four of them, and they would be vertices. I'm going to write that down so you can see it. I'll spell it correctly today. V-E-R-T-I-C-E-S, vertices, just like so. Yesterday we talked about these things. We talked about consecutive sides. Those are sides that are right next to each other. For instance, AB and BC are consecutive sides. So basically, as we go around clockwise or counterclockwise, the ones that are sort of adjacent. The ones that are adjacent. Non-consecutive sides, for this example, would be like the ones across from each other. Consecutive angles are the ones that are next to each other. So A is next to B. A is also next to B. So from A, B and B are consecutive angles so that you could go around. Non-consecutive, like A and C, would be examples of non-consecutive angles. You can't like jump around like that. A diagonal polygon, someone read me a definition of diagonal. Just raise your hand, read me the definition of diagonal. We already did it. Sierra, what do we have?
segment that connects two non-consecutive verticals.
Vertices. So it's a segment. Got it? Oh boy. It's a segment that connects two non-consecutive consecutive vertices. Okay. And yesterday I may not have done the best job showing you this. A segment that connects two non-consecutive vertices. If we're at A, consecutive, well, it's right up here. Here's consecutive, here's non-consecutive. Okay, thanks for asking, I appreciate it. If we're at A, how many diagonals is A going to have? It's only going to have one, okay? It goes over here to C, okay? But then if we go to over here to B, how many diagonals does B have? It has one, it looks like this, okay? At C, how many diagonals does C have? Well, it has one that's already up there. And here's D, well, it has one that's already up there. So we've drawn all of them, okay? And the idea here is that if we have a four-sided object, a quadrilateral, it'll always have two less than it, so it'll have only two. If we have a 10-sided object, it should have 8 diagonals. If we have a 20-sided object, it should have 18. It's always two less diagonals.
So it can't be an odd number.
Well, it's always two less diagonals than the number of sides. So if we have 19, then there'd be 17 diagonals. Okay? 19 sided would have 17. Any questions on this? Okay. I think we're drawing diagonals for the next thing, if I remember right. Apparently my computer's running a little bit slow, so hopefully it's recording all this and hopefully we go. Okay, a polygon is blank if no diagonals outside. We're looking at either convex or concave. Convex. Okay, and this one must be concave if there's one on the outside. So this one right here, it's concave, because look, there's like it's a dented in area right there. That's concave. This one over here is what we think of as normal. The reason we don't really think of the word convex is because convex for us is just normal. Concave is kind of the one we kind of talk about a little bit more because it's not normal. Dented in is not normal. Okay. Let's see. Name the diagonals of the quadrilateral. I'm actually going to go through and draw them. So if we start here at A, we don't draw one to B, but we can draw one to C. If we start over here at B, we can draw one over to D. That one's pretty easy. Okay, and both those are inside, correct? They both are inside, so that's what tells us this is definitely convex. Okay. For this one, if we start over here at A, we'll draw this over to C. We go over here to B. Ooh, we have to draw one over here to D, and that's going to be a mess, right? That's on the outside now. Okay. C already has its drawn. D has its drawn. So there's only two. So when we name them, we name this AC. Do we have to put any notation with it? Yeah, it's a line segment, so we got to put that over there. And this one would be BD. We're going to put that guy over there. Just a straight line over it. No arrows on it because it stops at those specific spots. Why don't you guys name these two over here? Put the one on the right. You guys go ahead. You name them. Hopefully those are the two that you had. Remember that you could name them. You could say line segment CA. That's fine. You could also name it line segment DB. It's the same thing as BD. Yes, ma'am.
So even though you had to go outside of the shape to make the B and D, the diagonal would still affect the S that.
It is a diagonal. Yep. You still call it a diagonal. It is a diagonal. That's by definition of what a diagonal is. Yep. That's right. Any questions on this? Sweet. Next page. Does it look familiar?
Yes.
Let's do it again really fast. 3 sides.
Triangle.
Triangle. Write it down. The more times you write it, the better you'll get. 4 sides. Quadrilaterals. Quadri. Lateral. Quadrilateral. Okay. 5 sides. Pentagon. 6. Like we're doing a 6, 6, 6. Hexagon. Or 6 as an X. X as an X. 7. Heptagon. 8. Octagon. Like an octopus. 9. Nonagon. Nonagon. 10. Decagon. Deca. Gon. 11. Decagon. Okay. Decagon. So it's meaning 1, and deca meaning 10, so it's 1 plus 10. Decagon. And 12. Decagon. They're pronounced almost the same way here. There's decagon, there's decagon, decagon. Okay? And what about N? N-gon. Remember my joke yesterday? Doggone. We had polygon had dog sides, would be doggone. Not dog-o-gon, it's doggone. Okay? Questions on that? Sweet, we're moving, guys. 2 polygons are congruent if and only if. What 2 things do you need in order to have your
Sides?
I'll start with that. All corresponding sides. You said sides, right? Oh man. Okay, well I'll do this. I'll say all corresponding sides are congruent. That's a comma. awful. And all, all corresponding angles are congruent. Made it. All corresponding sides are congruent, and all corresponding angles are congruent. It needs to be both. All corresponding sides are congruent. All corresponding angles are congruent. All corresponding sides are congruent. All corresponding sides are congruent. I think I said that. Angles are congruent. All sides, all angles. But that has to be the corresponding one. It doesn't have to be all the angles are like 30 degrees. Like this one's 30, this one's 30, this one's 45, this one's 45. Whatever it turns out to be. Okay. Is everybody okay with that definition? All corresponding sides are congruent, and all corresponding angles are congruent. All right. How could you, we haven't talked about specifically that this is a trapezoid. We haven't talked about it being a trapezoid yet. But how could you name this polygon?
Quadrilateral.
Okay, you can name it a quadrilateral. And it's also convex, isn't it?
Yeah.
Is it convex quadrilateral?
That was all.
In general, it's a convex quadrilateral. And you would probably also name it it's A, B, C, D. Okay. The second one, I'm honestly not even sure what we're supposed to be putting here. So you can also name this one as a convex quadrilateral, E, F, G, H. It works fine. We'll talk about it. Sometimes we'll talk about why these guys, you'll have to name stuff and you'll have to give it at least two characteristics, whether it's convex, concave, whether it's obtuse, right, scalene. We'll get into all that stuff later on. Isosceles, you got it. Equilateral, equiangular. The blank of a polygon equals the sum of the lengths of its sides. The sum of the lengths of its sides means what? Perimeter. 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 Thanks. Blank polygons have sides that are equal measures. Equal measures. So we're talking about the sides. So equilateral. E, Q, U, I. And here's this word lateral again. It's the same word, equilateral. It's not supposed to look like two words, it's just one word, equilateral.
Equilateral doesn't have an
It does.
I. An I after the I.
Oh.
Right. Equilateral. Hey, polygons have angles of equal measure. Equal angles is what? Equiangular. Good job pronouncing that. That was really good. Equiangular. It sounds so weird. First time I heard that word, I was like, what are you saying? Equiangular. I don't know where I'm going to put that. Okay. And some polygons are both equilateral and equiangular. So what are those called? Regular. Regular. If you're speaking Spanish. Regular. Are we okay?
I did it.
That's kind of a big review from yesterday. Okay. Now we're going to draw stuff. An equilateral triangle, ABC. You guys draw it? No. On your mark, get set, go. I'll give you 3 seconds. 3, 2, 1. Okay. Here's mine. Mine looks like this. A, B, C. Hey, how do I know it's equilateral? I better put these guys on there. Okay? Better put those guys on there so that I know that side AB, you can even write this if you really want it. Check this out. AB is congruent to BC. It's congruent to AC. Bam. Check it. There it is. All three sides are congruent. We are good. Okay?
We have to write that every time though?
No. Marks, that's what the marks mean. Also, additionally with this, I just want to review this. Is this also angular?
Well, all angles are equal.
Yeah, it is. Basically just for triangles. The triangle, if it's equilateral, it'll also be equiangular. That doesn't always happen for all shapes, just keep that in mind. But for this one, we could also mark each of these angles being the same as well. Each of them will be 60 degrees. Okay? It'd be 60, 60, and 60. That's just how many degrees are in there. You guys all right? You okay?
Yeah, there's a fly.
There's a bug.
A bug? Oh no! What are we gonna do?
Kill it?
We should have a red alert.
Yeah.
Close all doors. Code red. Holy smokes.
We just have a.
Evacuate the building.
Okay. I'm
Okay,
down.
number 2. You guys have 5 seconds. Draw it. Oh, I'll give you 6 seconds since there's 6 sides. Regular hexagon. Regular hexagon. You better draw it nicely. Somebody made fun of me yesterday, Andrew.
Bacon tweeting.
Oh yeah, you draw it.
And mine looks deformed. Yours looks worse.
I know.
Wow, that's like perfect. Yours is. Look how good his is.
Is mine done? Is it good? No, it's not. Because it's not regular yet. What do I need to make it to be regular?
A little line.
I need all these for each one of the sides.
Oh.
Additionally, what else do I need? I need some for each of the angles. So boom, 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 boom. Calm down. It's a fly.
They bite.
House flies do not bite.
Yes, they do.
It didn't have fun. It's fly. They like.
That's hilarious. Concave pentagon. Concave pentagon. Be careful of this. It'll probably look a lot like a square, just so you know. Concave. Concave pentagon. You guys go through, draw this. Probably like a dented in square is what we're thinking about. Square that's dented in. Concave pentagon. Probably the easiest way to draw it. Yours might look different than mine. My wife's an art teacher, so she thought it was ashamed of me whenever I start drawing stuff. Oh. Concave pentagon. How do you know it's a pentagon? Has 5 sides. Count your sides. Make sure there's 5. 1, 2, 3, 4, 5. I'm good. There should also be 5 vertices. And when you name that, it has to go around either clockwise or counterclockwise in this order that it gives you, just so you know. So P, Q, R, S, T. If I could have done it the opposite way, you can start it anywhere and end it anywhere as long as it goes around consecutively. Okay? And you could have had tons of other stuff on there. That's just what I had. Wow, it looks like a lot of people have the same one I have. That's weird. Number 4, convex octagon. Good luck.
What?
Convex octagon. Think of a stop sign.
I'm dead.
But it doesn't have to be. It just has to have 8 sides. It just has to have 8 sides. It has to be all on the outside.
It's almost as bad as mine.
Wow. Let's see that I have named this thing A, B, C, D, E, F, G, H. Okay. Alright, so yours. It should have 8 sides. Count them. Make sure there's 8 sides.
Yeah.
Make sure there's 8 vertices. Make sure each one of those 8 vertices are labeled with a point, like they're labeled, and they should be capital letters. And as you go around, either clockwise or counterclockwise, they should be in alphabetical order, just like they named them here. It has to be just named like that. Is that okay?
Yes.
We're okay. I know I'm giving you like a whole lot of things that you need to have on there. It just, there's a lot of details involved. Okay, number 5. Name the diagonals of number 3. Where's he at?
He's right on the keyboard.
Serious on my keyboard?
He's right there. On the little keyboard.
On number 5, right?
I'll hit him.
Hold on. Distracted. Oh, I almost had.
He almost
It
did.
wasn't even close. Wasn't even close. Okay,
It was
look
an
at this.
effort. I'm sure
Okay.
he's scared.
Look, 0, 0. I almost had him. Okay. Name the diagonals of number 3 above. Well, this is going to be awkward. Number 3 above. Okay, so here's number 3. We got to name the diagonals. So my diagonals are going to be like this. Yours might be different because of how you named it, so don't copy off of me. You got to figure yours out. My diagonals from P, there's going to be one over here. It's going to be one over here. Well, that's going to be a mess. From Q, it's going to be up to T. It's also going to be over here to S, or this is going to be a huge mess. R is going to be over here to T. Oh, this is overlapping so much. This is not good. Over to P.
He keeps attacking to himself.
You better list your own. Because these are going to be a big mess.
Oh, but I do what you do.
You gotta redraw.
Well, mine's on a different page. Mine are going to be P, R,
You got it.
S, R, P, S, okay. Q, T, well, that's good. You might have different ones than me. Q, S,
TP.
and
Yeah.
R. Do I have that one?
I think there's only 5.
I think there's only 5 as well. Okay, and yours might be different than mine depending on how you named yours. It all depends on how you named them. Okay, and the one that's which is the external diagonal for mine. Mine's PS is the external diagonal. So just kind of keep that in mind. Yours might be different depending on how you named yours. So that's number 5 is completely up to the way that you did your number 3. Wow. Name the side of number 4. That's gonna be a mess. Actually, that's pretty easy. Okay. Hopefully everyone should be the same on this one. AD, BC, CD, GE, FG. So where does it stop? Is there an I as well? Everyone should have the same ones in those. Because hopefully you. There's no I?
Talk to 8.
AB first.
I don't know. I have mine. Oh, it has a J. That's what it has. All right. Oh, number 4.
Number
He
17.
said he wants to jump, but he
Where's number 4 at?
Oh, almost done.
Oh. Well, there should be 8 of them though, right? A, B, B, C, C, D, D, E, E, F. Oh, I missed F. Did I miss F?
Yeah.
I missed F. Okay.
Mr. No.
Sorry about it. Turn the alphabet. Ah, take that. Okay. There should be 8 of them. Okay. Is everybody good? Up through 6? Up through 6. Number 7. You guys try 7 on your own. Try 8 on your own as well. 7 and 8 on your own.
Equal angle.
Equiangular quadrilateral. Try to make it not equilateral. Not equilateral. Make sure it's equiangular though. Mr. What?
Yeah, you what?
Mr. Levinsky.
Yes, sir.
Yes, how can I help you? Oh, that was terrible. 2 congruent pentagons. you guys for drawing your own pentagons. Oh boy, there's a few there. That's gonna be a problem.
Oh, you know my dad.
You know that P.
But why can't you draw two separate ones with the same letter?
Because that letter P is gonna have like one set of coordinates. It can't be in two different places at the same time. So if like that's point P, I can't have another point P over here and another point P over here. There's only one P. There can be. There can be only one P. No, I got confused myself. Oh, it's alright. I missed the Q, Q. That's not even in the right order. You guys are confused because you keep talking to me while I'm drawing this.
Oh.
Okay, hey, why do they need to be connected? Why do they need to be connected? Right, because we have a P here, and we have a P here. Since there's a P in two places, in two different polygons, it has to be the same P. There can only be one point P. There can be only one. Okay? So that's where we're at. You're so confused? Why are you confused? Are you confused? Who's confused? Some of you guys are just trying to make this hard. Okay? Guys, this is an awesome packet to keep because this is huge. We will honestly, so chapter 1, unit 1 is all about vocabulary. You know why we're hitting so much vocabulary? It's all about vocabulary, and this is the vocabulary that we will use throughout the entire year. Seriously, most classes say that, but honestly, we will talk about polygons, we'll talk about sides, we'll talk about equilateral, equiangular, we'll talk about quadrilaterals. We'll do this whole unit on quadrilaterals for a while. We'll talk all about triangles for a little while. We will do this. All this vocabulary we do use over and over again. So I appreciate your guys' hard work on this.